Hello everyone. Today we are going to talk more about error analysis. In the last class we have stopped at absolute error, mean absolute error and relative or fractional error section. And today we are going to discuss these using some key examples. So let's take straight away an example here, and then we are talking about finding out. We have some diameter of the wire, and that diameter has been measured by a screw gauge. I'm going to talk about screw gauge later on, how does the instrument work, and so on. But some measurements with the screw gauge for the diameter of the wire, and the values are these. Now you need to note here that whenever you are using any kind of instrument and you want to find out an accurate or near to accurate result, it's important that you take a number of measurement and take the mean of that value, because every instrument has got some kind of restrictions. So let's start off with the first calculation. Here we are going to find out what is the mean value of the diameter. Now in your low classes you might have already have an idea of what do you mean by mean value, so this is the simplest. So what we do here is whatever are the diameter measurements, we are going to take each of them, and there are 1, 2, 3, 4 and 5 values, and hence we are going to divide it by 5, and finally we are going to get a result which is 2.626 centimeter. Please note we have taken up to 3 decimal places here, because if you look into these values, all of them are corrected up to the third decimal place, and hence the answer we are taking here is also up to the third decimal place. So it's 2.626. Okay, next we need to find out what is absolute error, and that is in each measurement. So that means I'm not going to take everything together, I'm going to take them individually and going to find out what is the absolute error in each measurement. So for the first case I have got A1, and here we can say that the mean value is 2.626 from above, and we are going to subtract the value of 2.620, that is the first value that we have here. So we have got a positive absolute error of 0.006. Similarly we can do other calculations, because this is one of the simplest part. Next, if you go to the next term, it's self-explanatory, because you can see that it talks about mean absolute error. So we have got here 5 values of absolute error. So if we take these 5 values here, if we take these 5 values here and then basically add them up and divide by 5, we are going to get the mean absolute error. Please note the term here is an absolute error, and we are going to find out the mean of that. So we are not going to consider the negative sign, and we are just going to take the modulus of the values. So if there is a negative sign here, for example this, we are not really going to consider this negative sign, and we're just going to take the values, that's all. And after that we divide it by 5 and finally get the result. Here also we are rounding it off to 3 decimal places, because all the values have got up to 3 decimal places. Okay, next, fractional error. Please note this is important, we'll come to use it later. So in the fractional error we are going to take the mean absolute error and divide it by the mean value of the diameter. So we have got the mean value and we have got the mean absolute error, and then finally we get the fractional error, which is plus minus 0.001. Now please, it's important to remember that when you are writing down any kind of error, the plus minus sign plays a very important role, because it talks about the tolerance. It can be plus of that or minus of that added to the original value. We'll see that now, because we're talking about percentage error. So once you have the fractional error, you just multiply that with 100 and you basically will have the percentage error. Finally, if we need to write down the diameter of the wire, because we have got 5 different values and we want to write down the diameter of the wire, what we do is we will take the diameter of the wire, and then the mean value will be there, and plus minus the percentage error. So you can say plus minus of 0.1%. In case you don't want to write down the percentage of value, you can also write it as plus minus 0.001, as we have got in the above case for fractional error. So that these are some of the error calculations that you need to do. Remember this example, because this will help you to remember how to use each of them. Okay. Next we are going to talk about combination of errors. So now let's consider we have got two values, let's say x1 and x2, and we want to combine them. Let's say we want to add them, so we can say x is equal to x1 plus x2. So that's a simple case, but in each of these there also might be some kind of error values, and here the trick is to understand that how to add up those error values. So we have got two volumes here, this value, and we have got one more volume here, and we have got the mean volume, and that's the error part. So the trick here is that when we are going to add up the values, so we have got, the question is calculate the sum and difference in volumes with error limits. So that error limit is very important. So we have got v1 and v2, and if you consider adding up v1 and v2, it's simple. We just take this 10.2 and 6.4 and we get one value here. But how do we tackle the error part? So that's what we're going to see here. You see that the error, let's denote it by delta of v, will also be an addition of v1 and v2, and of course there is a plus minus sign there because it's talking about errors here and the tolerance limit, and we are going to add both of them. Now you might ask that, okay, this is as same as that of the mean values being added, but the thing over here is that whether you are subtracting two volumes in this case or adding up two volumes, the errors will always get added up. So we have a subtracted value, that's this minus this. So we have got 16.6 plus minus 0.03, where the errors are added and the volumes are added. And when we talk about difference, we have got 3.8 plus minus 0.03. Here the value, this one is subtracted, but the errors will always be added. So that's the difference, because error talks about a tolerance limit both in the upper and the lower level. So it's important that we add up the errors and subtract the mean values if we are considering the difference of volumes. Okay, the final example for this session, we are going to talk about the mass and density of a solid sphere. And here it's said that the values which are given are these 12.4 plus minus 0.1 kg and 4.6 plus minus 0.2 kg per meter cubed. So that's the second part is density, and the first part is the weight. But we are going to calculate the volume of the sphere, and here also we have got the error limits which is supposed to be measured. Now look at this, we have got the value of mass as m plus minus delta m, and density as 4.6 plus minus 0.2 kg per meter cubed. So a simple expression for volume, if you just remember it in this way, density is equal to mass by volume. So if we want to find out volume, volume would be mass divided by density. So we have volume is equal to mass divided by density. So we have got 12.4 divided by 4.6 if we don't consider the error at this point, and we have got the volume as 2.7 meter cubed. So that's only the part where we were not considering the error, and we have rounded it off to 1 decimal place, because you can see here in both the cases 0.1 and 0.2. Hence we need to just round it off to the first decimal place. Okay, now when we're calculating the error, we are going to use the fractional error formula, if you remember from the previous example, and the fractional error is given by the error divided by the mean value. Now here we have just got one value of the volume, so we have got just one value, and this is the error in volume. Now volume error is a combination of the error of both mass and density. Hence the error which creeps in the volume after calculation should also have mass and density. Irrespective of whether the formula tells about division of values, multiplication of two values, addition of two values, or subtraction of two values, the errors are always added with a plus minus sign at the front. So we have got mass and density. We are adding up the errors, but this time we are adding up the fractional errors. So in this case, we have got delta V, and we can just take that V here, and we have got a cross multiplication, and this is the final formula that I'm going to use. And now it becomes very simple, because I know that the error in mass is 0.1 and the error in density is 0.2, and the total mass is 12.4 and the total density is 4.6, and if I do the calculation, I get the error as plus minus 0.14. Hence the final volume would be 2.7, which was easy to calculate, plus minus the error. So here it's important to understand how do we calculate an error for deriving a quantity, for a quantity which is dependent on two other variables, let's say mass and density, for example. So you can just pause at this moment and just take a look at this again, so that you clearly remember how to do it. That's all for this session. Thank you.